Hello everybody, how are you all? I hope you all are fine and safe. Okay, so today again I came up with two boards and here I have a chalk right here and yeah, I've written something here, just I will let you know that what is it. But yeah, today I'm gonna solve a question based on one and only Leibniz theorem. Actually, that question consists of Leibniz theorem plus limits, and yeah, that's all we need. And yeah, again, plus L hospitals rule. So these three will be in our question, and I'm gonna just have a question on my board in front of you. Okay. So we have the question as we have to solve a limit that x approaches pi over 4 of the integral from 2 to sec square of x ft dt over x square minus pi squared over 16, and that is given us as k over pi times f of a. Okay, just wait a second, let me just turn on my AC. Actually, I'm getting sweating and you will not be like, it's not good. Yep. So I have my AC turned on. Okay, so let's come up with the question. Right here we have. Okay. So this we have given a limit and an integral in the numerator, and in the denominator we have something like this. And we have to compare this, and we have to find k to the a. We have to find the value of k to the a. So I'm going to just write it over here to just save my space. Yeah. Eventually we need to find the value of k and n and k and a, and then only we can just compute this, right? So yeah, let's move on to question. And firstly, we will check after just plugging pi over 4 in the equation, like so. Our integral, if sec square x, when x is pi over 4, sec square of pi over 4 is 2. So integral from 2 to 2 is 0, right? And in the denominator we have pi over 4 whole squared minus pi squared over 16, which is eventually 0. So this is 0 by 0 form. So we have to just use L'Hopital rule. So using L hospital rule, and according to this rule we have as limit x approaches pi over 4. Let me just, my chalk is like, it's not good at all. Okay, yeah, I've taken another chalk. So we have limit x approaches pi over 4 of the integral from 2 to sec square of x ft dt over x squared minus pi squared over 16. And I'm just differentiating, partial differentiation with respect to x, and d over, no, not partially, actually we can just like this. Yeah, it's good. It's not necessary to have partial differentiation right here. We will have partial differentiation in our L'Hopital rule. Sorry, Leibniz rule, okay? So yeah, this is quite disgusting, and I'm just gonna take this interesting, like numerator as I, okay? Actually numerator as di, and then only I would compute. Okay, I will tell you why I took this as di, right? And this thing is just 2x, right? So in the denominator we will have like our limit is like this. So I took this thing as di, so I will just write di over here, and in the numerator we will have di, and in the denominator we will have 2x, and the differentiation of the derivative of constant is 0, right? So this is 0 and we have 2x. So just pause it for some time, pause it for some time, and I'm gonna compute this thing that I took right here, the integral from 2 to sec square of x ft dt, right? So yeah, using Leibniz rule, and what does this Leibniz rule says that I'm writing this, yeah, d over dx of integral psi of x from phi of x to psi of x of ft dt is nothing but the function at psi of x times the derivative of psi of x minus the function at phi of x times the derivative of phi of x. I hope you understand this thing, and I hope you very well know about this, just because this is a great rule. Actually, this is great rule that we will have. Like, this is the second rule, and the first rule is like this. That's the most important thing, and from the first rule we computed this. Actually, Leibniz computed this, not mine actually. Yeah, the first rule was of Leibniz. The main rule is the function consists of x and t, like two variables. Okay, yeah. So here it comes that the partial derivative of integral psi of x fx comma t dt. So it's like that the integral from phi of x to psi of x of derivative of f this function, derivative of this function with respect to x, and we have dt right here, right? And then plus the whole thing from here, that f of psi of x times the partial derivative of psi of x minus f of psi of x times the derivative of partial derivative of phi of x, right? So yeah, I need you to just note it down, just because this is a great rule and that's very important to understand it. Okay, so yeah, just for the instant, I'm just gonna use this thing for this thing. So like our di, I assumed it as from 2 to sec square of x, the integral from 2 to sec square of x ft dt. So here if I'm comparing, then my psi of x is sec square of x and the phi of x is 2. So yeah, just plug it in this thing, right? So after plugging it, f of psi of x, which is f of sec square of x times the derivative of sec square of x. Okay, so derivative of, actually this is dy by dx. So that's why I wrote this thing, just because to make sure that to make you know about the derivative of sec square of x. Most of you might not know about this thing. That's why I wrote it. And minus f of 2 times the derivative of a constant, which is 0. So this thing will be 0, right? Just because 0 times anything is 0. So we will have di as f of sec square of x, and the derivative of sec square of x I have written it as 2 sec square x times tan x. 2 sec square of x times tan x. So finally we have our di as 2 secant square of x times tan x times the function at a secant square of x. So, and now I'm just gonna write down this or write that di over here, and then let's see the value of limit comes out to be limit x tends to pi over 4 2 secant square x tan x f of secant square of x. This is f of actually f of secant square of x, and we have down as the denominator as 2x, right? So without any time waste, I'm just gonna plug 5 or 4 in the on the values of x. Okay, so we will have 2 sec square of pi over 4 times tan of pi over 4 f of sec square of pi over 4 and over the denominator 2 times pi over 4. So as you all know that 2 times secant square of pi over 4. Secant square and pi over 4 is 2, nothing but 2. Actually, secant of pi over 4 is root 2. So the square will be 2. So 2 times 2. And we have tan of pi over 4 is 1. So it doesn't matter. Secant is, that will be 2 over 2, 2. This is 4. So 2 times 2, and 2 will just move upward, right? So this will be 2 times over here. I hope you understand that this is pi over 2 in a denominator. So I made that 2 to the numerator. Yeah, that's simple mathematics. So we have in the numerator we have 8 times f of 2 over pi, and this was given as that, like if I'm writing it, 8 f of 2, 8 times f of 2 over pi is 8 times f of a over pi. So we can compare that k is 8 and a is 2, right? So now what we need to compute, that k was 8 and a was 2, so a to the 2, which is 64. So this is our final answer. So I hope you understand that. Yeah, that's a good question, I think, and it consists of a lot of mathematical, like good things like Leibniz theorem, L'Hospital rule, like this, and yeah, derivatives. Yeah, that's good. That's all. That's not that tough, but yeah, it looked great. And yeah, that's all for this video. And stay tuned for the next video. Thank you so much. Thank you so much.